Hello explorers and welcome to another video. Today we are doing some more advent of code. And this is chill time for me. It's doing some fun coding with you. So let's jump over to day number 2 and see what that has in store. So your flight departs in a few days from the coastal airport. The easiest way down the coast from here is Toboggan. So that's, I guess, some kind of sled or something. It's something that usually kids use to move along. The shopkeeper at the North Pole Toboggan rental shop is having a bad day. Something is wrong with our computers. We can't log in. You ask if you can take a look. Their password database seems to be corrupted. Some of the password wouldn't have been allowed by the official Toboggan corporate policy that was in effect when they were chosen. To try to debug the problem, they have created a list, your puzzle input, of passwords according to the corrupted database and the corporate policy when the password was set. For example, you have this list. For each line here, the given password and the policy. So the policy is the first one here, and then we have the password. The password policy indicates the lowest and the highest number of times a specific letter must appear in the password. So here we see that A can be 1 to 3 times inside of this, but not more or less. So that's what we have here. And for this example here, 2 passwords are okay. This first one, we have 1 to 3 A's, and we see that we have 1 A, so that's okay. This is not okay because we need 1 to 3 B's, and we don't have any B's. And this is 2 to 9 C's, and here we have a lot of C's, but it's less than 9, or it's exactly 9, I think. 1, 2, 3, 4, 5. 1, 2, 3, 4. So it's 9. So that's okay as well. So what we need here is, first off, a lot of parsing, as we need to create something that we can parse out these passwords. And then we need some function that can validate these functions. So let's jump over to my editor here. So this here is some kind of parsing problem. And my first thought here is that we know a lot about data. So let's say that we have a public class or a private class. Let's say password. And we know that this password has, and now I will use public variables. It's not something that I usually do. So it has a minimum amount of a specific character. If we have a public, perhaps we don't need to sign these, maximum amount of a specific character. And then we have a public string of a character then. There, so that's the character, and then public string of password. So these are the data we have, and we could have a public function is valid to make it valid. So that we could do. And in that case, we have a character that we need to count within a password and see how many we have. So the easiest way to do that in Java, do we have something that tells us how many times a string occurs within another string? Java, how many times a string occurs in a string? It seems that more people have searched for that. Yeah, and it seems like there is a little bit of a counter here. Here we have find with matches. That seems even better because we only need a specific character. So that would be very handy, I think. We have used that before. So I think that's the nicest way we can do this. And I'm not sure if we actually need to... Yeah, we can compile the pattern because we have the same character each time. And I don't think we need to do this much more advanced than just having the password like that. And then we can have this password here. We add the matcher and the pattern. So usually when I use this, I compile some patterns in advance, and then I do a lot of matching on different things. And I use this quite often in my daily work in order to find regular expressions within words. So here we just need to check that min is equal or less than the matches, and max is equal or more than matches. So I wonder if we need to put these in front here, perhaps. So it equal or more, equal or less. So that should be the is valid thingy. So if we have this password up here, let's say that we create a password, new password, and then we take this password, give it a character A, we give it a password of A, B, C, D, E. So that's one of our puzzle inputs. And then we give it a minimum or maximum of 3, minimum of 1. And it's always this private thingy that I don't really like. We should be able to put that in a new class, password, like that, and then copy everything over there. I think that's a cleaner solution to separate our concerns, like that. And if we go back here, we have this problem solved. So if we run this, run the right days puzzle, and we need to system out print line password is valid. So let's see here. It's true. And if we say 2 here, we should get that it's false. Yeah. So we have something that can probably validate this. If we have all these C's that we had in the last example, like that, then we have 2 to 9 was the last example. We try that as well. So that's false. Yeah, I've turned them around. Turn around every now and then. I feel a little bit lonely. Yeah, so now it's true. So it seems like our validate function works well. Now I would like to, let's say, put this thing in up here in order to just create the password class. So let's see here, that's one of our inputs, right? Let's go back to this. We can actually take the input that we had here, so we actually have the same thing. Yeah. So that's what we want to create. We create a constructor here, and this is what we want to parse. So first off, I want to separate the password and the metadata. So let's do a string, multiple, or S array. And here we have the string split on that. And in that case, we have the string metadata is the first part here. So S array 0. And then we have the password, which is the S array second part here. We can trim that as well, just so we don't get any extras. And we can do the same here to be sure that we don't have any extra things. And then we need to do the same with the metadata. But here we need to separate on space. So let's continue to use this S array. And here we have, let's continue with metadata. No, not really. Let's see. String occurrence is the S array first part. So that's how many times things occur. And then we have S array of the second part here that we put into our character. And we trim that as well, so we have it clean. And then we take the last part of occurrence and do another split of the dash. And here we want the minimum to be the first part. So integer value of that part, and then we have the maximum of the second part. So now I think we have parsed all of this, and we haven't really taken into account that it can be some issues here. So let's see, number format exception, yes. Because we did metadata and not occurrence. So that was a good catch. So now we got true on the first one. So now we should be able to try this with the other ones as well. So let's go back to this, copy these, and then put in the second one and keep the third one in memory. So the second one was false and the third one is truthy. Okay. So now we have a way to create a new password class that we then can validate. So let's see here. How many passwords are valid according to their policies? That's our problem. And we can take some of the information from the earlier here. We can actually do this buffered reader thing and just put that into our puzzle here. And yeah, let's do this try catch thing. Catch exception, just so we handle all the errors that might occur. So let's see. Here the only thing we need here is actually to validate each line. Like that. And if the line validates to true, so we want to run the is valid on this as well, then we will valid passwords, increment that one. So I think this is pretty much all we need to do, and create a local variable for that. Yeah, put that up here, start by 0, and then we need some output here. System out print line valid password. So let's see if we can run this without any issues. I can think that we have passwords that aren't correct, and so index out of bounds exception, of course. So let's see here. We got that on some line. So let's put here some string debug, and then for each of these we add the line to debug, and when we get the error we just output the debug value. Debug. See here, what does it say? The debug might not have been initialized. Yeah, not our problem. So let's see what the debug value say. Okay, it's still not really wanting to go there. So let's put something into it. So yeah, because I used the wrong puzzle input. So let's change that up. So that's why we didn't get it. And we actually got a number this time. So the interesting thing here to take away is that in order to check in your catch statement what value actually did go wrong inside of the catch statement, you need to create a value outside of the try catch in order to have it inside of the result down there. So that's why I created bug up here, and then I set it everywhere in here because I know that here somewhere it could fail, and then I will have that value outside of the try catch. But let's see if 586 is the correct value. So let's put it in here, submit it. And that was right. You get a gold star, I get a gold star, everybody gets a gold star. So let's look at part 2. Part 2, while it appears that you validated the passwords correctly, they don't seem to be the official Toboggan corporate authentication system is expecting. The shopkeeper suddenly realizes that he just accidentally explained the password policy rules from his job at a sled rental down the street. The official Toboggan corporate policy actually works a little differently. Each policy actually describes 2 positions in the password. There where 1 means the first character and 2 means the second character, and so on. Be careful, Toboggan corporate policies have no concept of index 0. Exactly one of these positions must contain the given letter. Other occurrences of the letter are irrelevant for this purpose of the policy enforcement. So given the same example list, the first one is valid. It contains A at position 1 but not 3. And here we have invalid because it doesn't contain it at 3 or 1 or 3. And this one, 2 or 9, is invalid for both exceptions, both positions. 2 and position 9 contains a C. So it can only be one of them, but not both. See, exactly one of these positions must contain the given letter. How many passwords are valid according to the interpretation of the policies? So we have a different policy. But as we have created this password class, we now know that the only thing we need to do is redo this is valid. So let's call this is valid sled. And then we create another one is valid toboggan. Let's see if it's spelled like that. Yeah, so that's what we want to check out. We don't want the sled, we want the toboggan. So now we need something different. We need to get the position or the value at position, so character at position. So first off, if the string, let's see, the password length is less than min or password length is less than max. If anything of that is, then it's just false. Otherwise, return true. So let's see here. And we want to get the first and the last, first and second occurrence. And in order to get that, we want to take the password and take min plus 1 into the first. Could that work? Type are expected found a Java string, okay? So to char array perhaps, and then we can do min plus 1 and then put that into a new string like that perhaps. Cannot resolve constructor string char. Okay. New char array. Could that be something? So that's the first, and then we have the second and max. So now we do a lot of juggling of types here. So let's just do a system out of this first and second value, just so we see that we get something here. That seems reasonable. We forgot parentheses. Let's see here. We got debug and we got 3, 4 and DTTT. Okay. And 3, 4. So 4 is out of bounds for this exception. I guess we need to do minus instead. Okay, so we get a lot of letters here. So that seems great. So if we have this character and that equals first and not second. Let's see. If it equals first and not second, we can do this in multiple ways. We can either say if they are both equal, if both are equal, then return false. So that's one way. And if they are both not equal, so both are untrue, then we have false as well. But in the other case, the last case that we have left is that one of them is equal and not the other one. So I think that's a pretty simple way to write it. So let's see how many. We got 352 if we have that example. So let's see if that's correct. And then we can go through the code again. So let's put that in here and submit. And it's right! You get a gold star, I get a gold star, everybody gets a gold star. So let's see here, we go back to the code. So the valid toboggan policy here is that we first want to do some just arrow checking, so we have the minimum and the maximum within the length of this string. So we don't want the max value to be larger than the password length or the min value. Min value is probably unlikely, but we just do it for good measure. And then we want to check, get the first and the second one. And in Java, if you have something that is a string, and you want a specific character out of it, you can, I think, get char at position. So you get the current position, the character at a specific position. I don't think you can get a new string. You can do a split and you can do substring, but those are a bit harder to manage. So what I did, I just said, I want a character array, and a string is just an array of character. And you can create a new string with an array of character. And in this case, I created an array of character with just one character, because I thought that was simple enough, and then created a new string out of that. So if we like, we can do char at here. That should be similar and perhaps a little bit less code, a few less characters. And that should work equally well. And when we have gotten this character here, I just check the equilibrity of these. And if they are equal to both of them, they said that that's not a valid case, because just one can be valid at a time. And if both are untrue, then none of them are valid. And the only case we have left then is that one of them is valid. So then I return true. So this is the way I solved it. I hope that you found this interesting. I hope that you learned something today. If you have another solution that you think is more suitable, please leave some code in the comment section down below. I read all comments. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.